Welcome to the SAR channel, where sound and audio are demystified. Digital audio workstations are computer systems designed for recording, storing, editing, and managing audio. They can do most of what a traditional recording studio does and are widely used in music production. Because personal computers and audio software are now affordable, professionals, musicians, and home users all use digital audio workstations. These systems greatly boost both productivity and creativity. Digital audio workstations allow random access storage, multitrack recording, and playback. Their features can include nondestructive editing, digital signal processing for mixing, EQ, compression, and reverb, precise synchronization to timecode, data backup, networking, removable media, external device control, sound cue assembly, and analog digital inputs and outputs. Usually, a digital audio workstation runs on a personal computer with dedicated audio hardware or plug-in software that adds specific features. They support multiple tracks through time division multiplexing, meaning the number of tracks doesn't have to match the number of physical outputs. In theory, there can be unlimited virtual tracks, but disk speed and the number of connections limit how many can play back at once. Adding more drives can increase track count, but hardware I/O still sets a limit. Digital audio workstations use a visual interface controlled by a mouse and keyboard, though some also include a hardware controller. Most systems have standard tape-style transport controls, markers for locations, and punch-in/punch-out functions. Time displays can show minutes and seconds, musical bars and beats, SMPTE timecode, or film frames. Tools let users move, align, and sync tracks, zoom in to the sample level for detailed editing, and apply effects like fades, crossfades, normalization, gain or tempo changes, pitch shifts, time stretching, and morphing. Digital audio workstations can also act like virtual mixing consoles. The screen shows an image of a mixer with both audio and MIDI tracks. Users can adjust volume, panning, EQ, mute, solo, record, assign outputs, and automate controls. VU meters show signal levels in clipping. Tracks can be combined non-destructively before the final mix. Digital processing handles all editing, mixing, filtering, EQ, reverb, and other effects. Digital filters can offer different types and smooth transitions between settings. Most digital audio workstations run on standard Apple or PC computers, but some are standalone systems built specifically for audio work. Audio workstation software lets users record, edit, process, and analyze sound. These programs can work in different time modes, such as samples, frames, musical measures, beats, or SMPTE timecodes. They also handle file conversion between formats like WAV and AIFF and can create and edit samples while connecting with MIDI instruments. Users can select any part of a sound file, from one sample to the entire recording, and apply processing. Time compression and expansion allow sounds to be sped up or slowed down. The pitch can be shifted to change the key, fix out-of-tune vocals, or adjust timing, moving notes earlier or later, shortening or lengthening them without affecting pitch. These tools can target full phrases, single notes, or even parts of notes. Many programs include analysis tools. A spectrum analyzer plugin, for example, uses a fast Fourier transform, FFT, to show how sound behaves across frequencies. The results can appear as a frequency graph, a moving waterfall display, or a spectrogram showing changes in frequency and loudness over time. Advanced users can adjust FFT size, overlap, and smoothing for more detailed analysis. Noise reduction plugins can remove unwanted sounds like hiss, hum, or rumble by identifying and subtracting them from the audio. The software analyzes a section with only noise to create a noise print using FFT, then filters it out while preserving the desired signal. Users can fine-tune the process by adjusting how much noise is removed and how quickly the effect responds. Plugins can also remove vinyl clicks or even add vintage noises for effect. Editing is one of the main functions of any workstation. With random access storage, instant playback, level adjustment, marking, and crossfading, edits are fast and non-destructive. Mistakes can be undone easily. Using cursors, clipboards, and cut-and-paste tools, users can perform precise edits down to the sample level. Like old tape editing, sound can be scrubbed back and forth to find the right spot, or the point can be entered by timecode. Crossfades can be set manually or automatically, with adjustable duration, position, and fade shape. Most edits involve cutting, copying, replacing, aligning, or looping. Cut moves audio from one spot to another while removing it from the original. There are several types. Basic cuts join two parts, cut/insert moves one part to a new place, delete/cut removes a section, and wipe removes silence. Copy makes a duplicate in another place without changing the original. It can also combine or insert segments. Replace swaps one section with another, either keeping or changing their lengths, or even replacing it with silence. Align edits shift sections to match timecode references, synchronize with other tracks, or apply timing offsets between systems. Variations include sync alignment, trim alignment, and offset alignment. Loop edits repeat a selected section seamlessly, marking its length and destination track. When edits are made, all changes are stored in an edit list rather than altering the actual sound file. This allows for easy revision, efficient memory use, and flexible editing. A complex session results in a compact database of edit commands and settings. Each move is virtual, not physical, keeping the original audio intact. If you've enjoyed this video so far, please hit the subscribe button for more. Thank you. Many professionals use both PC-based and dedicated audio workstations for production and post-production work. These systems handle tasks such as music composition, recording, video sound enhancement, sound design, effects creation, editing to picture, Foley, ADR, automatic dialogue replacement, and mixing. A single workstation can combine the functions of a multitrack recorder, sequencer, drum machine, synthesizer, sampler, effects processor, and mixing console, while also connecting through MIDI, SMPTE, and clock interfaces to audio and video gear. Some workstations are built specifically for certain types of work. Film and video soundtracks benefit greatly from a workstation's ability to synchronize and access any point instantly. The system can quickly lock to timecode, even variable speeds, and allows easy movement of individual tracks or cues. Editors can insert or delete music without losing sync, and sound effects can be matched to slow-motion visuals while staying perfectly timed. In post-production, audio work is usually divided into dialogue, music, effects, Foley, atmosphere, and mixing. Many sounds in films are recreated from scratch. A workstation is ideal for this because it can handle multiple sound elements independently, align and layer them precisely, adjust timing and duration, and process sounds without damaging quality. Since all transfers remain digital, there is no loss in fidelity. In Foley work, footsteps and natural effects are recorded to match the action on screen. With a workstation, these sounds can be recorded, edited, and fitted to picture easily. Sound libraries can also be accessed instantly, removing the need for a physical Foley stage. Hundreds of sound variations can be sequenced to create the desired effects. Likewise, ambient background sounds, like city noise or party chatter, can be layered, looped, crossfaded, and triggered by edit lists to create rich soundscapes. Dialogue replacement is also faster. Multiple takes can be combined using cue points, then synced perfectly to the film. Room ambience from location recordings can be looped and mixed into new dialogue tracks for realism. A workstation can also serve as a main MIDI controller and sequencer. It allows the user to reroute MIDI signals, filter messages like aftertouch, send patch or volume changes, and control song position pointers. MIDI data can be imported for tighter timing precision. Workstations integrate seamlessly with SMPTE timecode. Editors can set timecode in and out points to create hit lists, assign offsets for one or more events, add or remove blank frames to shift timings, and move track elements without disrupting the rest of the project. Commercial and broadcast production also benefits from this flexibility. Segments can be arranged on separate tracks and automatically triggered by timecode for efficient playback and synchronization. Some digital audio workstations include video features that let users edit video and sync sound directly to picture. With video capture tools, a movie can appear in a small window beside the audio tools, though using a second monitor for full-screen playback is better. Audio tracks can be prepared for movies with instant access to multiple takes, and authoring tools can combine sound and video into the final project. Video systems are generally described as linear, nonlinear, offline, or online, though the lines between them have blurred. Linear systems use videotape, while nonlinear systems use hard drives. Offline systems are often used to assemble rough edits and create an edit decision list, EDL, which is later transferred to a higher quality online system for final production. Increasingly, modern nonlinear online workstations can handle every step, from editing to post-production, with professional quality. Workstations for audio and video offer various frame rates, sample rates, pre-roll and post-roll functions, and other features needed for synchronization. Some can even control external videotape recorders directly. Video is stored using compression to reduce file size and data load. To ensure smooth playback, video files on hard drives are often defragmented. Depending on the workflow, either the audio or video track can act as the master. Editors can scrub video frame by frame while dropping audio precisely in place, or they can keep the video paused while moving through the audio separately. Unlike tape systems, there's no waiting for rewinding. Everything happens instantly. With external machine control, users can preview the combined project while watching the original video and then record the final synchronized mix back to a digital video or audio recorder. During sessions, video clips can be captured from analog sources, and audio clips can also be recorded in mono or stereo at various sample rates and bit depths, depending on the sound card. Already digitized clips can be imported directly into the project. Once all clips are in the workspace, authoring software allows the user to preview, edit, and arrange them into a full movie. Audio and video tracks can be linked for synchronized editing or separated for individual adjustments. Users can set in out points and markers for transitions like fades. All editing is non-destructive, meaning the original files stay untouched. Only playback instructions are changed and can be modified endlessly. Edited audio and video clips can be aligned and mixed with adjustable volume levels. Finally, the completed project can be exported as a digital movie or recorded to videotape or optical disc using compatible hardware. Thank you for watching till the end. To better understand each video, make sure to watch the previous ones. Some may serve as prerequisites for the next. If you have any questions or opinions, feel free to leave a comment. Until next time, subscribe and stay curious.